Hello, I'm Lewis and this is DIY Machines, the channel where I get to share with you step by step how to build your own awesome projects. For today's project, I'm going to show you how to build your very own awesome smart magic mirror. We've got a built-in presence sensor here at the top to turn off the display when nobody's around. Alongside this is our built-in dimmable lighting, which looks rather cool, and yes, sometimes it has an attitude problem. There are absolutely loads of third-party modules which you can add to your mirror. This one shows you what you're listening to on Spotify. The wooden frame for the project is made from some common low-cost pine which I picked up at the local builder's yard. It was then primed and painted with some chalk paint. The electronics are relatively simple and quite easy to put together. I'll explain every step in detail for you. This video has been sponsored by PCBWay. I'll tell you some more about them later on. Now you're going to need a few things to build one of these for yourself. I've put a list of these items down below the video. You're going to need some wood for the frame, a monitor or screen, a Raspberry Pi, SD card and power supply, a PIR motion sensor and HDMI cable. You'll also need the two-way mirror surface itself. Now you can either order this as a made-to-measure sheet of glass, or do what I did and get yourself a clear sheet of acrylic or Perspex and then apply some two-way mirror film on top of this. I'll show you how I did this later in the video. For the optional front lighting, grab yourself some LED cob lights, a power supply, a dimmer control, and some aluminium diffusion channels. This is the display that I'll be putting inside of my magic mirror. So if I check the width, it's approximately 53 centimeters. You'll want to order your mirror to be at least 5 centimeters wider than your display, which is why I've ordered this large sheet of acrylic here from Trent Plastics here in the UK, measuring 70 centimeters in width and 1.5 meters in height. That's a lot taller than the display, but I want mine to be a full-size dressing mirror. There are so many different ways of building a wooden frame. I'm going for a relatively simple design, which will consist of 4 pieces of wood mited at the corners. Our piece of mirror will then sit on the back of this and be enclosed with a further 4 pieces of wood. On screen now, I've listed the lengths of wood and size of mirror sheet that I used in my mirror. If you want to make yours a different size, then I've made a simple free tool on my website, which you can input the widths of your wood and the size of your mirror sheet, and it will let you know what lengths to cut them before adding miters at the ends. Before we assemble the front of our wooden frame, I'm going to router a 135 centimeter slot down the front of the face of the 2 side pieces. This is to house the aluminium extrusion for the LEDs. I'm going to make mine the same depth and width so that they sit flush with the surface. Now, as I mentioned earlier, adding LED lights onto the front of your frame like this is an optional step, though I think it makes the frame look really rather quite good. To pass the wires through from the front side to the reverse, we can drill a hole at the end of the channel towards the middle of the frame. I then routed out a bit of a channel on the reverse to help run the wires through beneath the second rear part of the frame, whilst being very careful not to go too far and breach the side of the wall, as you'll see this from the front later. Now our PIR sensor is going to be housed in the front of our frame at the top in the center. To do this, I'm going to use a router to reduce the depth of the wood, followed by a Forstner drill bit that matches the width of the Fresnel lens on the front of the motion sensor. I'm not going to push it too far through because I want to limit its field of view so it only detects people when they're stood directly in front of the mirror's frame. We're now ready to assemble the front frame. To put mine together, I'm using a combination of pocket holes and wood glue. The pocket holes themselves are added to our two shortest lengths of wood, the top and bottom pieces. We can then smear the contact surfaces with plenty of wood glue. And then we can drive the wood screws in to hold everything nice and tight together. My glue suggested I let it cure for 24 hours before putting any stress on these joints. I strongly encourage you to check your glue as well, as it may be different than mine. Be sure to keep checking the diagonal measurements to ensure everything is nice and rectangular. Once dry, we can loosely lay the acrylic sheet in place for reference, followed by the wood which we cut earlier for the rear frame. Now that we know that we've got the right dimensions for our wooden frame, we can cut a notch in the bottom of this top section to accommodate the PIR sensor, as when it's nestled inside of the frame, its rear legs protrude ever so slightly. I used the Forstner bit again to remove a lot of the material, followed by a handsaw and some questionable chiseling skills. Now, as our electronics are generating heat, we should also take the opportunity to add a couple of holes in this top piece to allow warm air to rise and escape. On the bottom piece, we'll also drill a few more air holes for the cooler air to enter from the bottom of our project. So as you can see, it's going to be very tricky to fit the PIR sensor in here after we've attached the rear frame to the front frame. So before we do that, we'll add a set of wires to the pins on the back of our motion sensor and then install this with some hot melt glue. Another one of the areas that will be tricky to get to later are the holes we made in our channels for our LEDs. So before we fix the frame on again, we'll thread a couple of wires for the positive and negative of our LEDs through the holes, leaving both ends unconnected for now. After we finish decorating the frame, we can then solder the LEDs onto this and the power supply onto the other ends. Now that we've finished pre-wiring the difficult to access areas, we can attach the rear frame to the front of our magic mirror. Now I'm going to use wood glue and some band clamps to assemble the rear frame. Once this is cured, I'm then going to use more wood glue to attach the rear one to the front one, using multiple clamps to hold it firmly together whilst the glue dries. If you wanted to, on your project, you could use some mechanical fixings such as metal L brackets or wood screws. It's a good idea to use a tape measure to check all four corners at the same distance from the edge of your front frame. I then used a pencil to mark this so that after I applied the wood glue, it was easy enough to ensure the frame was still centered before I clamped it down into place. Also, make sure that you've got your wires on the inside of the frame and not going towards the outside. After allowing the wood glue another 24 hours to cure, I set about using my sander to tidy up where two different pieces of wood meet but aren't quite level. Once this was done, I used some sandable caulk to fill in the gaps around the frame before sanding this back down to a nice level surface. I also used it to infill any particularly deep knots that I found on the outside of the frame. After I'd worked from the grits, starting at 180 up to about 320, I decided to add a coat of priming paint to the surface first. I chose this grey one as it's going to help cover up the wood grain of the frame. Now you might choose to use an alternative finish depending on your preferences. You could, for example, use a whitewash if you still wanted to see the grain come through the finish. Or if you've used a particularly nice species of wood, you might choose to stain it and then finish it with a wax or varnish. Once the paint had been allowed to fully cure, I lightly went over and denibbed the paint using some finer 240 grit sandpaper. This basically means that you're lightly taking off any of the grains that have popped up as they've absorbed moisture from the previous paint applications. I denibbed between each application of paint or primer. For now, we finished working on our wooden frame and we'll turn our attention to the mirrored surface which will sit inside of this. If you've ordered yourself some pre-cut glass mirror, then you can skip this next step. But if, like me, you've opted for a sheet of clear Perspex or acrylic and some two-way mirror film, then I'm going to show you how to apply this with this small piece here, as it's going to be easier on camera than on the large sheet. So the trick to having good success when installing your two-way mirror film is to have yourself to hand a spray bottle of very slightly soapy water, and I recommend using some sort of squeegee with some cloth on the end. So the first step is to have a look on both sides of your acrylic sheet or Perspex. You might find that one side is labelled as being the show face. We're going to want this side to face outwards on our finished mirror project, so we're going to apply our mirror film on the other side. Step 2 is measuring and cutting your mirror film to a size just slightly larger than your piece of acrylic. We can set this to the side for a moment and remove the protective film on our sheet. Lightly spray the surface with your water solution. Step 5 is removing the protective film that you'll find on the two-way mirror. You'll probably find using a couple of pieces of tape is a great way to start the separation. You should then spray this film liberally with your soap and water mix. Step number 7 is applying it to the acrylic surface. Use your squeegee here to push out as much water as possible. And finally, you can use a sharp knife to go around the edges and trim off the excess film. So to show you the finished effect, I removed the other side of protective film and placed it in front of my iPad. The process for doing this on a larger piece of acrylic is nearly identical. However, as you can see, using these larger pieces of film and acrylic makes the process just a little bit trickier to handle. So slow down, take your time, and you should be just fine. My finished mirror surface isn't perfect, but I'm pretty happy with it, and I'm glad that I'm far less likely to break it than if I used a glass mirrored surface instead. Now that we have our mirror prepared, we can put it inside of our frame. First thing you want to do is make sure that all of your wires are tucked up out of the way. Now, as you can see already, on the bright side of the room up above the mirror, we can see a very reflective surface. But if we were to go underneath, from under here, you can see it's a lot more transparent. I'm going to use a step down drill bit to make some holes through the acrylic so that I can fix it into place using some small screws. So the next thing we can do is secure our monitor inside the mirror frame. To do this, place your mirror inside the frame. And then I've gone ahead and cut 2 lengths of wood. one to hold the monitor in place from underneath, and a second to keep it pressed up against the rear of the mirror. To secure these, I've decided to use a pocket hole. This way, if I need to in the future, I can simply remove the screw to retrieve the monitor. For the front of our mirror to be an effective mirror, we'll need to prevent any light from reaching the rear surface where we don't have the display. If you think your mirror is going to be up against the wall perfectly well, and the edges will seal out any light, then that's just fine. However, I don't trust mine to do that, so I'm going to use some tape and sheets of cardboard to cover the rear surface of the mirror. Hello, Future Lewis here. Just wanted to stop by and let you know that I would actually recommend using black cardboard, as this will improve the reflectivity of your project at the end. Let's now finish work on our embedded LEDs running down the channels on the front of our frame. Cut your LED channels to length. The aluminium is soft, so I just used my circular saw for this. For me, they simply push fitted into the channels without the need for any adhesive. You can then cut yourself 2 lengths of the LEDs, ensuring that you cut through them where it's marked safe to do so. We can then use the sticky back self-adhesive to fit these inside of the channels. Solder these to the wires coming through our frame from earlier. You can then fit the plastic diffusers themselves. To tidy up the ends of these, I 3D printed some end caps and a shroud to go around the PIR sensor. A small dab of hot melt glue is all it will take to hold these in place. So I've just gone ahead and connected my LEDs to my benchtop power supply on the floor down here, so I could check if they work and see how cool they look, and I think it's looking pretty awesome. The next thing we can do is install the button to control these LEDs. That's this thing here. Now I'm going to install mine up here in the top right corner, and this will allow us to tap it to turn the lights on or off, whilst a longer press will allow us to adjust the brightness. I'm going to place some tape over where I'm about to drill. This will help stop the drill bit wandering as we start the drilling process, as well as keeping a tidier finish to the edge of our hole. To drill through the acrylic, I'll be using that same step down drill bit that I used earlier. To finish the wiring of our LEDs, I'm going to use a few things. This is an extension lead, double-sided sticky tape, a couple of Wago connectors, a 24-volt power supply, and a female DC barrel which I've already extended with 2 wires. I fixed the electrical extension in place with some double-sided tape. The power supply is then connected between this and the dimmer button. The female DC barrel is connected to the output, which is then connected to the 2 LED strips with those wiring connection blocks, ensuring you correctly connect the positive and negative wires to their own connectors. Now we can prepare our Raspberry Pi with our Magic Mirror software, as well as create a configuration file so you can personalize the look and functionality of your own project. As an overview and put simply, this involves flashing the Raspberry Pi OS onto our SD card and configuring some network connectivity. Once we've done this, we can install the free open source Magic Mirror software and set about configuring our system to work with the motion sensor that we've added to the project, and boot automatically after the power has been switched on. Now it's considerably easier to follow software steps when you can copy and paste commands as I run you through how to install the software. So to this end, I have written this section of this guide out as a written tutorial freely available on my website, diymachines.co.uk. Once you've finished that, pop back here and we'll finish installing the hardware into the reverse of your magic mirror. I 3D printed a case for the Pi using 3D Jake's PLA plastic. Then I connected it to its USB power supply before then connecting it to the monitor via a HDMI cable. I then used some more of the double-sided sticky tape to secure the Raspberry Pi in place. The next thing that we'll need to connect to our Raspberry Pi is our PIR sensor here at the top, as we're going to be using this to turn the monitor on and off depending on whether we detect someone in front of the mirror. To do this, we'll need to connect the 3 wires that we added to the motion sensor earlier. I'm going to connect them to a DuPont style connector. Now, I've made a separate video already showing you how to do this, and it's easier than you think it might be. You'll find a link to this video in the corner, but basically you need to connect the 5V and ground leads to the relevant points on the Raspberry Pi, and then the output of the PIR sensor to pin number 4 on the Pi. If you don't want to add a DuPont style connector to your wires, then you can consider soldering them directly to the Raspberry Pi or using a solderless header to connect them as well. The next thing to do is to plug in the power for your monitor. I tidied away the wires with some more blue tape. To help tidy up the air inlet holes and the PIR cutout, I 3D printed a couple of pieces which I simply glued into place with some hot melt glue. So my mirror is intended to lean up against a wall for support, but if you wanted to hang yours on the wall, I'd recommend something like a split batten, as it's quite a heavy project. And if you wanted to have it entirely freestanding, then I'd suggest adding a leg on the rear side. As mentioned at the beginning of this video, you can use any combination of monitor and mirror size that you like, as long as the mirror is bigger than the monitor, of course. I'm really quite happy with how this project has turned out. I will admit that my application of the mirror film could be a little bit better, but I'm proud of this and I hope you'll enjoy building one of your own as well. Thank you so much to the kind folk at PCBWay who helped sponsor this video. Even though I didn't need a PCB in it, they were happy to help out. If you need a PCB for your personal project or workplace, then head on over to PCBWay.com. Whilst I've been working on developing my amateur PCB building skills, their eagle-eyed technicians have been very good at spotting potential errors and raising them with me before the fabrication process begins. This has been invaluable as a learning aid, plus it saves an awful lot of time in turning around mistakes. If you want to give PCB design a go, then I strongly encourage you to do so. It's not as tricky as you might think, and at the moment, if you're a new customer to PCBWay, they'll give you a $5 coupon, and being as 5 small PCBs are only $5, you effectively only need to pay for the shipping. And get yourself a sheet of clear acrylic, and the height will be 5 centimeters. Success once you fix the rear frame are the through hole. Ow, Jesus, what's that?